I wasn't recording it. So the question is the 240-foot line, is it this?
No.
No, what is it? It's the ground, yeah. Right, so the shadow is 240 feet long, and so there's the shadow right there that we're measuring, right, from the edge of the building. Okay? So remember to use radians in your calculations. We want to express our answer in inches per minute. Okay, so what are we going to do here? Snapshot values. Okay, so let's maybe add a variable or two. That we've got a theta. Is there any other variable that we need in our L, or how about if we call it X? Call that distance X right there for the length of the shadow. Okay. So then what values do we have? Do I need to put a variable on here?
Yes. No. Yes. Why?
Well, okay, now you tell me. Do I want to put a variable there?
Yes.
Why? Okay, how come?
Because you need to find, use the 3 sine cos tan.
Okay, I'm going to probably need to use a trig function.
Yeah.
Hunter, it sounded like you had an opinion about that.
Wait, what's that 70 on the side?
Okay, it's a 70-foot building.
Okay, so shouldn't that be on the other side? You don't need a variable.
Right, and we don't want a variable because the 70 feet is not varying, it's staying the same.
Oh.
Right, so we're just gonna call this distance right here 70 feet, that is, right? But now look at the bottom, it says express your answer in inches per minute. So if our answer is supposed to be in inches per minute, what kind of linear measure do we want? We can't be mixing and matching, right?
Times it by 12.
We gotta be multiplying by 12 to get everything in terms of inches, right?
I know.
Okay, so,
70 inches.
right, 70 feet to inches, and then probably also we want our snapshot values in terms of inches, right?
Okay. Keep it all in feet and at the end times it by 12.
You could, yeah, we could,
That's smaller numbers.
we could, that's fine too. It doesn't really make any difference. We're gonna let our calculator probably do all the heavy lifting of calculations anyway. Okay, so looking at this then, what are the snapshot values? We're going to look at one frame in our film or our movie, and the frame is this one, right? When the shadow is 240 feet long,
We got
etc.
the X.
Okay, so we know X.
Oh, but do we times that by 12 or should we wait till the end?
But we can do it. I'd say do it now.
Yeah. Why not?
So X equals 70 times 12, which is 840.
Wait, wouldn't you divide it?
Yes.
No.
No, because X is this, right? We're going to multiply because inches are smaller measures than
Yes.
feet. Okay, so we're going to get 840 inches. What else do we know?
We know the 72 buildings.
Oh, whoops, that's not X though. Sorry,
It's actually 240.
that's the height, isn't it?
Oh,
Yeah.
Right,
Yeah.
Okay, so how about if we redraw this picture?
Good idea.
So this is theta. This is 840, and X is going to be what?
240 times 12.
240 times 12, which is 2,880.
Did you just do that in your head?
I did.
What?
How do you just say 24 times 12 and you add 0?
Yep.
Oh.
But math still don't fucking do it.
Okay. Yes.
So where did you get the equation of it times 12?
Well, because we want to put it in terms of inches. That's the only reason.
Okay.
I'll put the units on here.
Thank you. That's a lot better.
There we go. Okay. We won't have to use the units in our calculations, but we'll just so we keep track of what we're doing. Okay, anything else we know?
We know the rate of the angle change.
So theta dot.
Okay, theta dot. Okay, theta dot is 0.25 degrees per minute. Okay. So I'm going to say we want to probably change this into what?
Radians.
Into radians, but also into what? A minute. I mean, we don't want minutes in here, do we?
Seconds.
We want seconds. Oh, no, we do want minutes. Never mind. Never mind, we want minutes.
Oh,
We're good.
Make up your mind.
Okay, but we do want to change this into radians, right?
Yeah.
We need to change this into radians. So we need to, and does everybody kind of get why that is? You don't have to have a total understanding, but do you know when you need radians?
When they ask for you.
When they have,
Well,
But it doesn't say-
okay, when it's, sure, when
you're
we're,
not dealing with eight. No, you are.
okay, when we're dealing with angles, but when we're dealing with naked angles, which is really what would be
Naked.
naked. So they're not clothed inside of a trig function.
What?
If your answer wasn't, if you weren't looking for,
Theta itself.
if you're gonna be taking trig functions of all the angles, it wouldn't make any difference, right? Taking trig functions of the angles are gonna give us back a non-angle answer, we're gonna get back a numerical answer, and it doesn't really matter as long as we're consistent what angle type, what types of angle measures we're using, right? But if you're ever gonna have an angle by itself, where you wanna be able to, for example, the rate of change of an angle, in terms of like an amount, an angle, change in angle per unit time or something, when the angle is not hidden inside a trig function, then we do need to be using radians. And the short answer is, and I think we've talked about this before, whenever you mix and match linear measurements and angular measurements, then you have to use radians. Do you remember why that is? Think we talked about this, but real quick, this is probably something I'd like you guys to remember this. Radians mean something and degrees don't. Degrees are completely arbitrary, right? Whoever first came up with the concept of a degree, why did they pick 360 probably for a circle?
Please hold.
Kind of, but it's not a bad number to pick.
365 days a year. They're like, yeah, that's a number, that's cool.
Just round
Anybody know seriously why you think they probably would pick 360 instead of like 340 or something?
365 when the Earth goes around the sun. Yeah.
No.
A round circle.
Say it again. No, not really anything to do with pi.
Isn't it like honestly divisible?
Yeah, the answer is it's a highly divisible number. 360 has a lot of factors. So when we want to break a circle up into fractions, like a quarter circle or a sixth circle, those are all going to be integer numbers, or not all, but many of those are integer numbers for 360 because it's so highly divisible. Yes.
How can you get something that's real than something that's arbitrary?
Okay, so degrees is totally arbitrary, right?
But radians isn't.
Okay, but radians is not. The reason that radians
Like, doesn't-
are actually,
it's not tangible.
legitimate measures of an angle is that it comes from this relationship. We know that the arc length along a circle is equal to r times theta, right? Okay. Right. Arc length is equal to, so if we want to move along the circle a certain distance, the distance that we move is equal to the radius of the circle times the angle, right? Okay? So then we know in math, what is the radius, or excuse me, what is the circumference of a circle equal to? Well, okay, but in terms of an exact answer, the circumference of a circle is what? Circumference of a circle is what?
2 pi.
2 pi, right? And that's not up for debate. That's a geometric fact, right? I mean, in a flat space, the circumference of a circle is 2 pi. Okay, so then on a unit circle, we're going to let r equal 1, right? So if r is 1, we know that arc length is just equal to theta, right? And so if we want to establish some units for theta, or some way to measure theta, the way that we do it is we say, okay, well, on a unit circle, what would the arc length have been corresponding to an angle? So if we go all the way around once, what would theta be? That arc length would be the circumference.
2 pi.
And so 2 pi would correspond to an angular measure of all the way around once. So it really means something. And then of course from there we could say, half a revolution would be 180, quarter revolution, would be pi. Quarter revolution would be pi over 2, etc. And that's where we get all these radian measurements. So they actually mean something, right? There's a correlation between that angular measurement and the arc length along a unit circle, right? Okay, so that means something. So we need to be in radians. So how do we change from degrees to radians? Like any other kind of a changer.
Pi over 180.
Yeah, good. We're gonna multiply by some change here, and we wanna have degrees on the bottom so it cancels, right? And so what's the easiest way of saying an equivalent angle in terms of degrees and radians?
Pi over 180.
Yeah, pi radians is the equivalent of 180 degrees. And so if we do that, we get, what do we get? We get, let's see, 4, so that's gonna be
0.00138.
pi over 45, hold it, no, that's not right. Is that gonna be 1/4? So we're gonna get pi over 720.
Huh? Yeah.
Pi over 720 radians per minute, right?
No.
And radians are unit, they're really, it's a kind of a contrived unit.
Why is 720 bigger? Because 180 divided by 5.
Because 0.25 is just 1/4,
Oh, because
Right.
it gets much more.
so we'll call this a radian. Even though radians, it's not a true unit, but we'll call it a radian, that's fine. So there's theta dot, right? Okay. Written in terms of radians. What are we trying to find?
You're supposed to find x dot.
X dot. Okay, good. So we're trying to find the rate of change of the length of the shadow, right?
Yeah.
Okay, so then really what we've got here, this is X, we said, right?
Yeah.
So that's our picture. Okay, so how can we come up with a parent equation? Tangent would be good, wouldn't it? We want to come up with a parent equation that relates the x's and the thetas, right? Well, tangent's a good idea. Tangent, we know we can see tangent of theta is equal to what?
840 over x.
Okay, 840 over x, good. So then we're gonna have to differentiate this, right?
Huh? Did you just say? What did you just say?
We're gonna have to differentiate this implicitly
Oh, yes.
to relate the rates, right, to get our dots. Come up with Now, does anybody have any suggestions here? Now that I've written this big, I see something that would be useful to do here. Say it again. Listen, please. There shouldn't be any talking, listening. The y is a constant. You're right. Yeah. Right. So we don't need the quotient rule here, right? We could just write this as 840x to the minus 1. But even then, differentiating that is, I'm going to have to use chain rule, right?
Yeah.
Okay, does anybody see something I can do to this to make the derivative easier?
Times x on each side.
I could, but then I'm still going to have a product rule.
We have x.
Which side could we make easier? Now, the right side, what do you see about the right side here that would make it easier if we flipped it? It'd be easier, wouldn't it? If we flipped it, instead of having 840x to the minus 1, we would just have x over 840, which is the same as 1/840th times x. The 840 on the bottom is just a fractional constant, right? X on the top makes it really simple. Agreed? On the other side, does that cause problems? If we flip a tangent, what do we get? No, not an arctangent. Cotangent. Is the cotangent derivative really any harder than a tangent derivative?
Nope.
No. Right? So then why not, that's not an essential step, but it's a good step. Makes things easier.
It's the same.
So flip both sides?
So we're gonna flip both sides. So I'm gonna do this. I'm gonna exchange sides too. So we get x over 840 equals cotangent theta. Now we can differentiate
Yeah.
implicitly, right?
Would it almost be easier if we made it 840 cotangent theta equals x?
You can. That's fine to do. That 840 is just a constant, so you can
Yeah.
put it on either
Would
side.
it be easier that way?
Sure.
You wouldn't have to do the quotient rule.
Why not? Well, you hold it now.
Oh, you wouldn't be doing it, never mind.
Right.
Yeah,
You
no,
wouldn't be doing it anyway.
Yeah.
Right. So, but we could. It'd be fine.
So is x over?
Okay.
differentiate.
But the 840 on the bottom, that's fine, that's just a constant, right? That's the same thing, x divided by 840 is the same as 1 over 840 times x. What do we do with constants? Just leave them alone, leave them out front, right?
Yes.
So what's the derivative of the left side then?
X dot over 840.
X dot over 840.
Can you write that out?
Well, all we're saying there is that 1 over 840 times x is the same thing, right? As this. And so when I differentiate that, I just ignore the 1 over 840 and get an x dot. So the moral of the story is, whenever you have a constant on the bottom, you just treat it, just treat it as a constant, right? You don't need the quotient rule there, okay? Quotient stands for a quotient of functions. Okay, so what about the other side then? We're going to differentiate cotangent theta with respect to t. So what do we get? Cosecant squared theta times theta dot.
I never get how to do that. How do you do that?
We
Okay.
just have it in the back of our
Well, true,
I mean,
but
back of our.
true, but there's a reason for this, right? Because remember that we're not differentiating. If we were differentiating with respect to theta, well, the derivative of cotangent theta is just negative cosecant squared theta, right? But we're not. We're differentiating with respect to t, and so we have to use the chain rule here, right? We've got the derivative of cotangent of cotangent anything, right? The derivative of cotangent anything that's a variable is cosecant squared of hand, right? But then if we look inside that, the derivative of theta is not 1 because we're not differentiating with respect to theta. So we have to have whatever we're differentiating with respect to t, and so d theta dt is something. That's what we call a theta dot. Okay? So here's our answer, but what are we able to plug in? Well, we can plug in the theta dot. We don't even need the x at this point, right? Yes, Jane.
So how many of this is like off topic, but like on the test, like over this stuff, like is it gonna be all questions like this?
It'll be over related rates, just related. I mean, there'll be some. This is a pretty hard one, but yeah, I'll probably give you one hard one, and then the rest of them will be.
And how many?
Oh, I have to look back at that test. I might even rewrite it. I might even shorten it just a bit. I think there's 5. Yeah. Something like
How
that.
do you? One question
There's
or
less
you
ones.
don't have any. More questions are better.
Well, I know, I would agree, but we can't really do lots of, so in lieu of more questions, they'll give you more attempts. And you can get partial credit on some of these too. Yeah. Okay.
Wait, so I'm just gonna have Moodle?
Okay, but no. Okay, let's not get off track though. Let's stay on track here. So, what can we plug in? We can plug in theta dot, but we don't have the value of theta, right?
Yeah.
Okay, there's a couple ways we could go with this, once again. We could fill in, for our snapshot, we could calculate theta, right? It'd just be, we could say it's arc tangent of 840 over 2400, right? Or no, over 2880, right? So we could do that, and that's just a number, and that's fine. We could then just plug that into our expression here and be done. The other thing we could do though, is we could, for our snapshot, we could just calculate the third side, the missing side of this triangle, and then just write cosecant as a ratio, because all trig functions are just ratios of sides in a right triangle, right? So x is what? We said it was 2880, so I'll write that in red, so we know that's just a value of this variable for this snapshot, right? 2880, and so then we get, for our hypotenuse, the square root of 840 squared plus 2880 squared, which is what? I'm not going to do that one in my head. What's that going to be?
3,000.
3,000 exactly? Okay.
Wow, that's nice.
Okay, so now we've got the three sides of this triangle, and so cosecant would be the ratio of what two numbers then? Now, I always have to think of this in terms of cosecant's the reciprocal of what?
Sine.
Sine. And sine would involve,
3,000 over 840.
good, so 3,000 over 840, which we could write as 300 over 84, just to make it a little simpler, right? Okay, so then we end up with, if we solve for x dot, we get 840 times negative, what did we say it was, 300
Over
squared over,
Wait, what happened to the three, the cosecant?
Yeah.
that's what this is, right? That's this ratio, cosecant squared is that ratio right there, right?
Wait, because cosecant is sine, and if you flip the sine, it's gonna be.
It's cosecant is hypotenuse over opposite, right? Okay, agreed?
Yep.
Okay, times theta dot, which is, what did we say theta dot was? Pi over 720.
How is that gonna work though, cause they don't want the answer in pi?
No, we just plug it into our calculator.
Okay, and there's our theta dot. So what do we get here? So let's see, we get just a big number. So we could do this, right? And then we could do this, right? You don't have to, but just to make the calculation a little simpler. And then we just end up with negative, somebody just figure out what is 300 squared divided by 84.
9,000.
Okay.
Just kidding.
Negative 40.
No, 300 squared is 9,000.
Wait, why do we cross off 84 on that?
Because I canceled it off with one of those.
Oh my goodness, that's genius.
Right.
What?
Okay, so we got lots of stuff going on. Everybody focus, please. So, I mean, you see that you don't have to do those little tricks. Those little tricks were just if I have a 10 on the top and a 10 on the bottom, and all this stuff's being multiplied, I can cancel those zeros, right? Dividing top and bottom by 10. The 84 right here cancels with one of my 84s on the bottom, and so I'm left with negative 300 squared times pi over 84 times 72, right? So somebody, well, actually, I've got a calculator right here. I can do it.
74980.
Oops.
Negative 46.74. That's what I got.
Watch it.
So long.
Okay, so we get this, right? So we get about negative 46.75, but if we're gonna, I mean, so we'll just keep it to, like, what's it ask for? How much?
Yeah, but the calculator.
Well, no, it should be negative, and we'll see why. So we want it in inches per minute,
Oh, well, rate is the shadow decrease.
so it'd be about,
No, well, do multiplication.
so I guess I should probably specify how many sig figs. But let's just say we're gonna round this to the nearest tenth, right? So if we round it to the nearest tenth, our answer would be negative 46.7 inches per minute.
Why would it be
Okay.
negative
Okay.
though? Because negative 300 is being squared.
Okay, but it's not the negative 300. It's negative cosecant squared, right? So it's the cosecant that's being squared. The negative is a multiplier. Right, it's outside. Should it be negative? Look at the picture of it.
Yeah.
Yeah. No, okay, so what are we asking for? Yeah. Oh, okay. So the question is, being as the question is worded in this way, at what rate is it decreasing, our answer should be positive. We know it's decreasing. Does it make sense? Look at the picture here. Think about this picture. As theta increases, right, what does that imply about the length of the shadow? Well, if theta is getting bigger, then that means that the shadow has to be getting smaller, right?
Yes.
They're inversely related, so it makes sense. Okay?
Oh, yeah.
Right?
Yeah.
Okay. Very good.
So it's almost 14 a minute?
Yeah, at that time it is, yeah. Well, now, why is that the case? Because if the shadow's 240 feet long, 4 feet a minute's not that much, really, is it? Right? Does that make sense? I mean, and you can, 4 feet a minute, that's pretty fast, but that's reasonable.
Wait, oh, because our answer's in inches.
Mm-hmm. Or, yeah, our answer's in inches, yeah. Okay? All right. Is that all we have?
It's a Friday.
Okay. Okay, all right.
Let's do Martin Luther King trivia. Okay.
Yeah. Yeah. Yeah, that's fine. I thought this would be a good one to go through, though.
Yeah.
It seemed like it was.
Yeah.
Okay, trivia.
How do you